When you're designing a creature for a fantasy world, one of the things that you should always think about is how does it reproduce? The reason why you should consider this is because the purpose of evolution is reproduction. Not in terms of like the true purpose of the universe style. I mean, the thing that drives evolution is reproduction. And in most worlds that you build, you will probably have that same driving force. Because if you removed that driving force, so much would change, you would effectively be building a completely different animal society as well as world society and people society. So, how your critters reproduce is pretty important, from your plants right through to your animals. Today, let's talk about reproduction and how you can use it in fantasy to build interesting creatures. Welcome to another episode of Just in Time Worlds with your host, Marie Mullany. If you like these kinds of videos and you want to help me making more of them, you can hit my Ko-fi page down below or buy my epic fantasy books available at most retailers. Links to that down below as well. And thank you very much to all of my current supporters who help enormously in making these videos viable. Enough of that, let's crack on. Broadly speaking, there are two strategies to reproduction: asexual and sexual. Let's start our discussion by talking about asexual reproduction. There are a number of different ways in which creatures can reproduce asexually. The first is binary fission. This is where the cell splits, like the amoeba, into a clone. It is the most basic form of reproduction, and it's probably where it starts, but it has a very low mutation rate, and so it's not where reproduction's going to stay. It's just probably where it's going to start. Another form of asexual reproduction is budding. This is when a new plant buds onto another plant and grows until it's quite substantial and then drops off. An example of this is the freshwater plant, the hydra, that reproduces asexually in this fashion. Vegetative propagation is very similar to budding in that plantlets grow on specialized leaves until they are big enough to then become plants of their own. Examples of this is the mother of thousands plant in Madagascar. The main difference between vegetative propagation and budding is that in budding, the plant grows pretty much anywhere. In vegetative propagation, it grows in a special place, and it's like it's protected in this area. So vegetative propagation probably evolved to enhance budding. So budding is obviously quite susceptible to the plant getting broken off too early and so on, and then vegetative propagation kind of protects that plant a little bit. So there are certain schools of thought that say that spores are asexual reproduction, but in most cases, spores are actually a stage in sexual reproduction, which also involves reproducing through mitosis, like mushrooms. There are some forms of algae that propagate without gametes and therefore do only use spores. Much like a gamete does, a spore does contain genetic material, so you can use a spore to propagate with. Indeed, in Warhammer 40k, the orcs propagate by means of spores in an asexual manner. What this kind of propagation brings to the table is that you can have things just spawn without needing to worry about how long it takes them to grow or how long a generational cycle is, or that a male and a female needs to get together and boink, or whatever it is they need to do. That doesn't need to happen. Instead, you can just have spores spreading out and things jumping up. So it is a very interesting reproductive strategy on the asexual side. But we're not done with asexual yet, because there is also fragmentation. This is when you split an animal in two and two new creatures form, like for example with earthworms. This would, for me, be a creature that is very hard to kill. It's that kind of cut off its head and more heads grow kind of principle, or cut it in two and suddenly you're facing two of the enemy. So it's a very hardy animal, a very hard to kill animal. Probably an animal that has a lot of life energy. It would be interesting if you built a magical system that is dependent on harvesting life energy. But if you can find one of these creatures, you could, in theory, keep harvesting it over and over and over as it creates multiples of itself every time you fragment it. So it's an interesting thought to play around with that kind of fragmentation as sexual reproduction if you mix that up with magic. But we're still not done with asexual reproduction. Agamogenesis is any form of reproduction that does not involve a male gamete. So first I should probably explain that gametes are basically sperms and eggs, or any kind of, two things that you combine to form a zygot, which is the enough genetic material that it can grow into a sample of the species that, the combining part. Okay, so if you have a reproduction without the male gamete, with only the female gamete, it is called agamogenesis. And there's a couple of different types of agamogenesis. One of the fascinating ones is parthenogenesis, which is an unfertilized egg, an unfertilized female egg that develops into a new individual. This has been documented in over 2,000 species. Water fleas, stick insects, ants, bees, reptiles, fish, they all have parthenogenesis as a potential. Now, facultative parthenogenesis is when females can produce both sexually and asexually. They only reproduce asexually when they are forced to. So when finding a mate is really hard. An example of this is the zebra shark, who normally produces via mating for the genetic mix, right? Because the advantage of having male and female mix is that you have genetic material from both individuals forming a new individual. But in the zebra shark's case, if she struggles to find a mate, she will propagate through facultative parthenogenesis, where she propagates asexually. The biggest land animal that propagates like this is actually the Komodo dragon, and that beast comes in at 10 feet long and over 300 pounds in weight. There are also animals that propagate asexually or sexually at regular intervals. These are called heterogony females, and an example of this is aphids, which is a type of bug that engages in this type of reproduction. So they reproduce asexually in order to spam out winged offspring that can colonize a new plant. And then once they have the colony established, they start reproducing sexually in order to get the benefits of mixing the genetic material. So again, back to that spores concept, where you have the rapid spawning ability of asexual propagation. So you spam out things to colonize a world with, or whatever, and then later a mating pair will come once the colony's been established and the area pacified, and they will start breeding the true next generation by mixing their genetic material. But we have yet more in asexuality, and that is the obligate parthenogenesis. So this is where the female only reproduces asexually. So she cannot reproduce with a male. Desert grassland whiptail lizards is an example of this. Now, they are a hybrid species of two other lizard species, and generally, hybrids are not fertile. But the desert grassland whiptail lizard has established a stable population by means of what amounts to cloning, with this obligate parthenogenesis, where the unfertilized female egg will grow into a new individual that is effectively a clone of its mother. So in order to stimulate egg production, the females engage in sexual activities with each other. So they're also called the lesbian lizard for this reason. And that leads me to the last form of parthenogenesis, which is gynogenesis. This is a form of obligate parthenogenesis where a sperm cell is used to initiate reproduction. However, the sperm cell's genes never get incorporated into the egg cell. So it is used for the purpose of generating the egg cell, but it doesn't get incorporated. It never gets mixed in. An example of this is the Amazon molly fish. Now, because they don't use males in reproduction, there are no male Amazon molly fish, but they need sperm in order to generate the egg. So, males from a closely related species, the sailfin molly, do the girls from the Amazon molly a solid, and they lend them their sperm in order to have the eggs drop and become then clones of their mothers. And of course, the sailfin molly propagates normally with the females of the sailfin molly. I just thought that was fantastic, that you have the males of one species helping out the females of another species in order to propagate that species, as well as, of course, helping out their own species. So if you're looking for non-sexual reproduction, if you're looking for asexual reproduction in your critters, you have a lot of great examples that can feed really interesting behavior in both creatures, and if you take that all the way and make them sentient species, in sentient species. For example, those lizards that form clones. That could be a very interesting single-sex environment if you wanted to play with that as a concept, as a species that exists in your world. So if you enjoyed talking about asexual reproduction, hit the thumbs up button, and let's talk about sexual reproduction. Before we talk about mating and finding mates and all of those kinds of activities, there is a way to reproduce sexually without ever meeting each other. You just release the gametes. In a way, this is the way that trees do it, except that trees, of course, have co-evolved with insects and so on to allow them to spread the gametes so that they reach the right trees. And that is because it is harder to use this as a strategy on land than it is in water. This kind of sexual reproduction, where you just release the gametes into the water and let them fall where they may, is much more common in the ocean than it is on land. And this is in fact how corals propagate. Corals only propagate when the water temperature is correct and the moon is in the right phase. Now, it doesn't actually have anything to do with the phase of the moon. It has to do with the tides. In order for the gametes to have enough time to blend together and form the zygotes, you need to have reasonably calm waters, and that means that the tide needs to be in the right place. So if you have a world with multiple moons, remember to think about the effect that that tide has on the reproduction of things like coral that just release their gametes into the water, and come what may, hopefully the male gamete will find a female gamete and they'll form a little zygote together. So, and you can check out my thoughts on multiple moons in the information card. But this kind of release the gamete does have its limitations. It does mean that you have no certainty that the genes do propagate. So let's talk about mating. Before I get into mating, I should explain low investment gametes versus high investment gametes, or male and female gametes. But for me, this is more like the chicken and the pig and their relationship to breakfast. The chicken lays an egg, and that egg goes to the breakfast table. So the chicken is interested in breakfast. But the pig's invested in breakfast. And that's kind of how you need to think about low investment versus high investment gametes. The high investment gametes are those gametes where the partner who creates them is the one who looks after the child, generally speaking. This is generally the female of the species, but not always. For example, seahorses, despite the fact that they do carry the low investment gamete, will have a pouch where the female deposits the eggs inside of the male's pouch, and the male is the one who gets pregnant. The male is the one who looks after the children, which is really why this is a high investment gamete and the pig in the breakfast. It's the partner that looks after the child. And you can see this most clearly with flatworms. So flatworms are hermaphrodite. They're both male and female. They can produce both male and female gametes. When they mate, they will actually fight each other to see who becomes the male and the female in this particular mating, because the female will be the one stuck with the children, with the offspring, right? She's the one who produces the high investment gametes at that point. And the male gets to just slither on away and leave the female with a kid. And then in the next round of the mating ritual, again, there's a fight. And now, again, it's about who gets stuck with the offspring for the flatworm. So when you're thinking about your critters, think about who is the low investment gamete, who is the sperm giver, and who is the high investment gamete, who is the one that is invested in the child. And think about sometimes flipping that around. There's nothing wrong with having a seahorse or two that where the male or the low investment gamete is actually, in the end, the child rearer. So the big deal with mating is that you need to choose your mate. Mostly it will be the high investment gamete producer that will be choosing the mate. That's why males in birds and so on all have these proud displays like peacocks and so forth. It's to attract the female. It's to convince the female to mate with a male because she's the one with a high investment gamete. Again, seahorses flip that on their head, and it's the male who's courted by the females. But what happens if you struggle to find a female or a male, like our zebra shark, who then reproduces asexually? But that's not your only strategy viable for dealing with that situation. The hump-headed wrasse has got a very interesting strategy. If there are no males, the biggest female will change sex and will become a male hump-headed wrasse in order to mate with the other females in order to reproduce for the community. So that is an interesting sex change, but a really fascinating one is the clownfish. So in a clownfish community, there is one big female clownfish and one sexually mature male clownfish. All the other clownfish are juvenile. They are not sexually matured. If something were to happen to the female clownfish, the male clownfish would change into a female clownfish. He would grow bigger and he would become a high investment gamete producing female fish. And the biggest of the juvenile clownfish would mature into a male clownfish and would then mate with the now female clownfish to create the next generation. That means that Finding Nemo should have been a little less wholesome and a touch more Game of Thrones, if you see what I'm saying. Anyway, changing sex is not your only option in terms of finding males or females if they're scarce on the ground. The anglerfish also has an interesting strategy in that the female anglerfish, who is the big one in this case, the one with the light, actually has males attached to her and they feed from her veins. And in return for feeding her male fish, she gets to use their sperm whenever she needs it. And the reason why they've adapted this is because anglerfish live down in the desolate area of the ocean, so it is very hard to find each other. So when they find each other, they cling together very tightly. So you have some different strategies that would make sense to implement in a fantasy world. You could have a species, even a sentient species, that can change their sex either at will or due to environmental pressure, or maybe there's a special magical ritual that kind of mimics a environmental pressure that used to exist before the species gained control of their environment. So it's definitely worth thinking about how your creatures deal with finding it difficult to find a mate. But we've been spending a lot of time on water, so let's move a little bit to land-based reproduction. If you're engaged in land-based reproduction, you need more protection of the eggs, of the zygote. So in the ocean, you can have basically soft-shelled eggs mostly because the water itself will nurture and keep them hydrated. But on land, you need to protect the zygote. And that is why land-based animals that lay eggs will have hard shells around them. Now, if you have such an egg-laying critter, it is entirely possible that they can have male caregivers, and that, like with a seahorse, you can swap the caregiver from the gamete production. For example, the emperor penguin, the male emperor penguin is the one that carries the egg and hatches the egg despite the fact that it's produced by the female. So if you have egg-laying societies, it is definitely worth thinking about who is the actual caregiver and hatcher of the eggs, because mostly it will still be the partner who produces the high investment gamete, but not always. Sometimes it will be the partner who produces the low investment gamete due to whatever evolutionary pressures evoke this thing. But laying eggs still has some risks, and of course it doesn't fully protect the gamete, which is why some animals developed giving live birth. Now, there are two ways that you can give live birth. You can either give birth to a fully formed creature, which is how mammals do it, placenta mammals, or you can give birth to like a little itty-bitty tiny crawly worm thingy that goes and lives in a pouch and grows up the way marsupials do it. Now, the advantage of giving birth is obviously that you are protecting the little zygote while it grows up, and therefore it is much safer and much more likely to propagate. So you're much more likely to see this in species that don't produce masses of offspring. The reason why eggs are produced in large masses, especially in creatures that don't look after their eggs, like turtles and so on, they spam eggs because if they don't, their species wouldn't survive. So kind of the more care you give to your young, the less young you probably have. One other thing to remember about evolution and about mating is that it's very much not about the individual. This is not about what is best for the individual to survive. It is what is best for the genes to make it to the next generation. And nowhere is this more clear than in the insect world. The reason why the praying mantis eats her mate is because praying mantises who eat their mate lay more eggs. Yes, he dies, but his genes carry on. That means he's one. Bees die after they've mated with a queen. And the reason why is because bee queens take the sperm, the male gamete, they take it in a pouch, in a little sack-like receptacle. And another male can come and scrape out the male gamete to deposit his own into that little sack. And in order to prevent that, the most successful males evolved a means of detaching their penis in the sac to block other males from scooping out their sperm. And this kills them. The male bee does die doing this, in breaking off his penis in the female, in the queen. But his genes are propagated, and that means from an evolutionary perspective, he has won. So Bear that in mind when you're constructing propagation strategies for your creatures. It is not about the individual. It is about, do the genes make it to the next generation? If you enjoyed this video about propagation, hit the thumbs up button, let me know what you think. Maybe check out my video on matriarchies in Fantasy World. And if you want to connect around this or any other topic, I do have a Discord server linked down below. And I will see you soon for another episode of Just in Time Worlds.